Let's continue with our study on exponents and move to lesson 3, which is on page 77 of your student workbook. And we're going to look at something called integral exponents, okay? Integers, just to let you, or integral comes from the word integers, and integers you know from the numbers chapter. It's the negatives and the positives, including 0. And there's no decimals. So -5, -8, 13, 12, those are all integers. So we've only up to this point dealt with exponents that was either 0, so we dealt with the 0 exponent, and we dealt with positive exponents. And where we're going to focus today is what's going to happen if you get an exponent that's negative. So before we actually start dealing with integral exponents or the negative exponents specifically, let's just quickly do a review of the 0 exponent. So 0 exponent, essentially remember anything to the power of 0 is 1. So a to the power of 0 is 1. The only exception to this would be if I gave you a negative and then a to the power of 0. And I said, what would this be? You would say, okay, this negative is really a -1 times a to the power of 0. So that would be -1 times a to the power of 0 is 1. -1 times 1 is 1. Okay, so that was the 0 exponent. You were comfortable from the first 2 lessons with integers that were positive. Now let's deal with integers that are negative. So the negative exponent says complete the pattern below. And actually, we're not even going to use it as a pattern. We're just going to look at 10 to the power of 0, 3 to the power of 0, a to the power of 0. So anything to the power of 0 we know is 1. Now, let's say I said, what's 10 to the power of -2? You can do that on your calculator. So let's do 10 to the power of -2 and 3 to the power of -2 on our calculator. And I'll show you how you do it on your calculator, and then I'll show you the math behind it. So 10 to the power of -2 gives us a decimal, but you always want to convert your decimal back to a fraction. So 10 to the power of -2 is 1 over 100. 3 to the power of -2, if we typed that in our calculator, so 3 to the power of -2, we're going to get a fraction, and then we're going to convert it back to a decimal, and we're going to get 1 over 9. Okay, how does this work? Like, let's say I said I don't want you to use your calculator. Essentially what happens is 3 to the power of -2, so we've got a negative integer, right? We've got a negative number here. In order to make this negative exponent positive, here's what you do. Write this as a fraction over 1. And if you have a negative exponent and you bring it into the denominator, that -2 is going to become +2. And you know that 3 squared is 9. Okay? So let's, for example, look at this question, 3 to the -3. So 3 to the -3. What we're going to do in math is we're never going to write our exponents with a negative exponent. I always want you to change this to a positive number. So then you'll say, okay, she wants me to make that negative exponent positive. So right now it's over 1. If I bring that 3 to the power of -3 down into my denominator, what I get is my exponent, this negative, becomes positive. And 3 to the power of 3 is 27. Okay, so that's 1 over 27. So let's deal now with variables, right? Because how I could tell if students understand this is I give them something that they can't punch into their calculator. And that's always going to be your variables. So a to the power of -1, if I bring my a down, it becomes, I'm just going to, sorry, that's a mistake. So a to the power of -1 is over 1. If you bring your a down, that exponent changes from a negative to a positive. And then I don't need to write down a to the power of 1. I could just say 1 over a. You don't need that power of 1. So this guy, the next one, a to the -2. What that is equal to is 1 over a squared. This last one is going to be 1 over a cubed. Okay? If I did b, write the following with positive exponents. You say, okay, simple. Put these all over 1. The exponents are negative. And if you bring each exponent into the denominator, it is going to then become positive. So this is 10 to the power of 7. Sorry, 1 over 10 to the power of 7. This becomes 1 over 3 to the power of 5. And this becomes 1 over a to the power of n. Let's say, I want you to write this just if you have room off to the side somewhere. What we're eventually going to get to is the following. Let's say you get an answer once you combine all your exponent laws, and you get a to the negative 2, b to the 3, c to the negative 4. Okay. You would never submit this on a test as it stands because you're never going to submit an answer with a negative exponent. You have to make those positives. Okay. So what you would do is you would say, okay, this is all really over 1. So what I'm going to move down would be this. As soon as you move it to the bottom, that a becomes positive, and this moves down. That c becomes positive. Then the b stays where it is, and the b, because it's already got a positive exponent, it gets to stay in the numerator, and that would be your final answer. Okay, let's look at numbers now with negative exponents. So 5 to the power of 4 divided by 5 to the power of 7. I want you to do the same thing and write it with a division bar if it's a quotient. So that would be 5 to the power of 4 over 5 to the 7. This applies what we learned in lesson 1, right, when we did exponent laws. So bases are the same. You subtract exponents. So that would be 4 minus 7. 4 minus 7 is 5 to the power of negative 3. And then here is where you would say, okay, I've got to get rid of that negative. If I bring that 5 to the negative 3 down, it's going to become positive, and it's going to become 5 to the power of 3. And from there, I could evaluate what is 5 to the power of 3. So that's 5 times 5 times 5, which is 125. And that would be your answer. Okay. Um, this one here, complete a to the negative p. So we got to get that negative p positive, put it over 1, and that's going to be when you bring your power down, it's going to become 1 over a to the p. Again, you guys pause, do e, right? So write each one of these over 1. I want you to give me 2 answers. I want you to give me the answer with a positive exponent and then evaluate. So evaluate, remember, means to find your numerical value. Give me an answer. So this is going to be 1 over 2 to the 1, which is equal to 1 over 2. This one would be 1 over 3 squared, which is 1 over 9. This guy is 1 over 4 to the power of 3. And if you evaluate 4 to the power of 3, that's 4 times 4 times 4, which is 1 over 64. Okay. Flip your page and let's look at what happens when we have a negative exponent in the denominator. So before we actually do this, if I gave you 1 over a to the negative 3, and you're like, okay, well, where do I write my a if it's in the denominator, it's already on the bottom, and my exponent's negative? The answer is you always write it in the opposite of where it currently is. So if I wanted to get a positive exponent, now I'm going to write my answer in the numerator, and that would be a to the 3 over 1. And I don't need to put over 1, so the answer is just a to the 3. So again, if I gave you 1 over b to the negative 5, you would say, okay, I need to make that negative positive. That's going to be b to the 5. All right, let's look at this. Use the rule for division of fractions to show that this is equal to this. So what I do is I'm just going to deal with the left-hand side. 1 over 4 to the negative 3. To make that positive, I'm going to write it just becomes 4 to the 3. So if your exponent that's negative is on the bottom, bring it to the top. So that's going to be 4 to the power of 3, which is equal to what they've given me up here. Okay. Um, one thing I want to show you, let's do one with letters. So let's say I said, can you please simplify this for me? So write this down. A squared, b to the negative 3, c to the 4, d to the negative 2. How would we simplify this? I often talk about the variables. Are they happy or sad? They're happy if they have positive exponents. They're sad if they have negative exponents. If they have negative exponents, they have to move. So this a is happy. It's got a positive exponent. It gets to stay where it is. This c, which is in my denominator, is happy. It's positive. It stays where it is. This b is unhappy. I got to get rid of that negative exponent. I need to bring that b down. As soon as I write the b in the denominator, it becomes positive. And then I go to my last letter, which is d, and I say, okay, this guy's not happy. It's got a negative exponent. I need to bring the d up. And that would be your answer. Okay, let's look at class examples now. So again, bases are the same. We're going to be combining exponent laws. So it says simplify. So simplify basically means combine your exponent laws. It wants our answer with positive exponents. We will never answer with negative exponents. And then where possible, and then we're going to evaluate using a calculator. So let's do A. Bases are the same. This is the product law. You're going to add your exponents. So 5 plus negative 3, right? 5 plus negative 3. Hopefully you don't need to use a calculator for that. Like I'm hoping that you guys are beyond that. But 5 plus negative 3, if you need to double check, is 2. So that is my simplified expression. And then from here, that is equal to 16 when you evaluate. Bases are the same. You're going to add your exponents. When you add 2 plus negative 5, you're going to get negative 3. I need to rewrite that negative. I need to bring it down. 1 over 3 to the 3, and that is 1 over 27. So the two answers that I would box in would be they wanted the answer expressed with positive exponents. So it would be this, 1 over 3 to the 3, and that's 1 over 27. For C, write that in the numerator to make it positive. 2 to the power of 5 is 32. For D, bases are the same, so you write that 6, and then we're going to subtract. With division, I always tell my students to actually write it down. So negative 7 minus negative 5. Okay, so negative 7 minus negative 5. With division, and we're subtracting exponents, I often tell students, like, students when they do it quickly, they tend to get that wrong in their head. So I always say, you know what, you're always going to get your calculators for your test. Always double check. So negative 7 minus negative 5 gives me negative 2. So that's 6 to the power of negative 2. Now we got to get rid of that negative exponent. So that's going to be 1 over 6 squared. 1 over 6 squared is 1 over 36. So those two answers would get boxed in. This last guy, there's two different ways you could do this last one. Some students would say, can I do that power to a power? And the answer is yes. That's one of the ways that some students will answer this. So if we did power to a power, you would get 2 to the negative 3, which is 1 over 2 to the 3, which is 1 over 8. Okay, so that's what you would get if you do power to a power. Other students will say, okay, can I not do this? Can I make this negative 1 positive 1 by bringing that down? And I would say, yeah, absolutely, you could do that as well. So that would be 1 over 2 to the 3, now to the power of positive 1. Power to a power gives us 1 over 2 to the 3, which gives us 1, oops, which gives us 1 to the 8. So for what you're going to see when we continue with this is there's often going to be different ways that you could solve a single question as long as you're getting to the right answer by applying the correct laws. So I could have done this method or I could have done this method. Whichever method you prefer, you may do. Okay, identify the following as true or false. Bases are the same. We need to subtract the exponents. So 3 minus negative 1, two negatives make a positive. That would give me 8 to the power of 4. This is correct, therefore it's true. Okay? This one, 8 to the 3 over 4 to the negative 1. If your bases are different, you cannot divide those numbers. When we're dealing with exponent laws, bases must be the same. So this is false, right? What they did is they said, okay, I'm going to divide 8 divided by 2 or 8 divided by 4. We don't do that, right? We only do our exponent laws when bases are the same. Let's check if C is correct. In order to make that negative 3 positive, I need to write it down there, and I would get that. C is true. D, I really like. So star D. Students have a hard time sometimes with D, but it's a great question. What this is 9 times a to the negative 3. That negative 3 only applies to the a. Okay, it does not apply to the 9. I'll show you after we do this one when it would apply to that number in front. But as it's written, this is 9 times a to the negative 3. This is all over 1. This is what moves down, right? So that would be 9 remains in the numerator and a to the 3 goes to the denominator. So this should be my answer. So this guy is false. When you would move that 9 down is, let's say I gave you this. 9 in a bracket, a to the negative 3. Then this entire bracket is over 1. If I wrote that entire bracket to the power of negative 3, then that would be 1 over 9a to the 3. But then from here, I'd have to distribute the exponent in. Okay, so as it stands, this one here, the negative applies to the a, not to the 9. Okay, we'll do this last class example, and then I'll give you some homework, and that will be part 1. When you're done your homework and you've marked it, you could do part 2. Watch part 2. So, all right, state and simplify and write the answer with positive exponents. So, bases are the same. It's product law. You add the exponents. Negative 4 plus negative 3 is going to be negative 7. And that's going to be 1 over a to the 7 with a positive exponent. Division. Let's rewrite this with our division bar. 6x squared divided by 2x7. 6 divided by 2 is 3. X to the 2, quotient law would be x to the 2 minus 7. That would be x to the negative 5. Okay, here's a good question. This negative 5, does it apply to the x and the 3 or just the x? What do you guys think? I hope everybody says it only applies to the x, and that's what has to move down. So the answer is 3x to the 5. All right, let's do D together. There's an invisible number in front of the y. The coefficient is a 1. So if you type in your calculator 1 divided by 2 and you try to reduce that, it doesn't reduce, right? If you go 1 divided by 2 equals math 1 fraction, that stays as 1/2. I can't reduce that. So what I have is I have 1/2, and then I have y, and let's figure out how many y's I have. 6 minus -5. So I'll just write it off to the side here. 6 minus -5. You could punch that in your calculator, or you could say two negatives make a positive, and that's going to give me y to the 11. So it's 1/2 times y to the 11. Okay, that -3 applies to that bracket. So put that bracket over 1. If you want that -3 to become a +3, write it in the denominator. So it's -2 x to the 3. So the only thing that I change when I write it in my denominator is my -3 goes to a +3, but whatever was in the bracket stays exactly as is. Okay, so now that 3 applies to the -2, right? Make sure you type that in a bracket. -2 to the power of 3 is -8, x to the 3. And I'm done because the only thing I have to move is negative exponents, but my exponent is positive, right? So this is my final answer. Sometimes students will say to me, well, don't I have to move this -8 up here? And I'll say, no, this -8 is the coefficient in front of your x cubed, but this -8 is not an exponent. We only ever move negative exponents. E. 8 divided by 4 is 2. Oh, at first I was going to say, um, let's subtract -5 minus -3, but bases are different, right? So can I combine those exponents if my bases are different? And the answer is no. So I'm going to write down a to the -5, and I'm going to write down b to the -3. Now, this is correct, but it's not complete because you have to answer with positive exponents. So this A is unhappy, it comes down. This B is unhappy, it goes up. And this 2, I just keep it exactly where it is, right? I don't move that coefficient. I only move my exponents that are negative. Okay, this guy here, I'll start, it's probably the most challenging one. So this -2, in order to make it +2, I need to write that down. So 5p in a bracket. As soon as I write it in the denominator, that 5p goes down and that -2 becomes +2. There's already something in the denominator, so I need to include that. So 5q to the 4. And then some students will say, well, like, what do I write on top? When I bring this down, you can never just leave the numerator blank. There's always a 1 there, okay? So now what do? I can't really do anything with this 5q to the 4, but I could deal with this exponent here. So let's distribute that exponent onto the 5 and onto the p. So I'm going to get 1, 5q to the 4, 5 squared is 25, p squared, 1 over 5 times 25 is 125. And then some students will say, well, what do you want me to write, Q first or P first? Remember I said I want the letters like in descending order. So A goes before B, goes before C, X, Y, Z. So P comes in the alphabet before Q. So I'd write the P squared first and then the Q to the 4 last. And that would be your final answer. For your homework for this first part of lesson 3, I want you to do questions 1 to 4. And I have a note for myself, look at number 2 as a class. So we'll do number 2 together. So without using a calculator, show that these two are equivalent. Okay, so what I like to do is I like to only deal with the left-hand side of this equation. And it's what the left-hand side is 3 over 5 to the negative 2. So this, I don't want to deal with that negative exponent, right? We always want our exponents to be positive. Because it's on the bottom, if you bring it to the top, that negative 2 becomes positive 2. So I already have a 3 there. It has to stay. But now if I bring that 5 up, that negative 2 becomes positive 2. What this is equal to is 3 times 5 squared is 25, and 3 times 25 is 75. So that's how you would solve 3 divided by 5 to the power of negative 2, and how you would get 75 as an answer by showing me all of your work. Okay, so now you could do 1, 3, and 4. When you're done, check your work. When it's all right, you could watch part 2 for this lesson.